Hello. All right. In this video, I want to talk about how I think about absolute value functions. So like solving equations, inequalities, all that good stuff. All right. So when I graph these, I am graphing the left function and the right function, and I'm comparing them separately on Desmos. So if you look, I typed in the left over here and the right, and we want to see kind of where do these two functions cross, right? And so if you look, they're going to cross in two places, okay? Which shouldn't surprise you because quadratics, right, usually have two solutions, and absolute value functions usually have two because you have two distances, right? Think of their job. All right. So how do you solve any equation? You isolate an inverse, and then as humans, we love linear, we love quadratic. So we don't like this, right? We want to manipulate it to get into one of the two forms we like. So I'm going to isolate this function. How do you get rid of subtracting it? You use the inverse, right? So what is that? 18, okay? Again, I want to isolate this as much as I can. How do I get rid of multiplying by 3? Inverse. And so I get it down to, oops, that's minus, my absolute value function. Okay, as much as I can. All right, at this point, I know I have two answers. Because remember, if I run to the right 6 miles, run to the left 6 miles, my distance is 6. So this I could have ran, right, to the right, okay? But maybe I ran to the left, which is a direction of -6, okay? All right, but we want to solve, again, see how these turned into linear? Our absolute value function, eventually we got to something linear, which we like. Okay, so here we get 7, and then again, to get rid of that, we do the inverse. And I like to think of money and debt, so I owe $6, I have 1, I owe 5. Okay, so if I look at my graph, I want to see where the function 10, the constant function, crosses. So if I click here, notice I get my -5 answer. And when I have an input of a -5, notice I get an output of 10. And when I come over here, when I input 7, I get an output of 10. Okay, and so that's when my function is balanced with 10. Now, I'm going to pause it for a second because we could go down and look at this guy. Okay, so I'm going to pause and I'm going to type that into Desmos. We'll look at that. All right, we're moving again. Okay, so now this time I am graphing the manipulated function at the end. Okay, so I have the left absolute value of x minus 1 and the right is 6. And notice it doesn't look the same, I mean, as far as where it's located at, but it still has that V shape. So notice now when my input is 7, my output is 6. And when my input is -5, my output is 6, and it's balanced at those points. Okay, so I like to use this to help me find solutions to absolute value functions that are inequalities. And the reason is because if I can get these key points, then I don't need to know any of those rules of like, ooh, do I trap it? Do I not trap it? I don't memorize any of those. Okay, if you want to read the book, totally great. But I think of this as more from a visual perspective, and I solve it that way. So I'm going to pause. I'm going to erase all this, and I'll show you what I mean here. All right, we're moving. Okay, so I'm going to solve this like I did before. But notice now I want, when is this function greater than? All right, so again, I'm going to isolate my function like we did before. And I'm just going to skip a few steps here. All right, so, but before we had an equal sign, right? Okay, which is fine. All right, so we found that when x minus 1, pretend it's equal for a second, is 6, okay? So we got x equals 7, and then we did x minus 1 equals a -6, and we got, what did we get? -5, is that right? Okay, so, and I don't know if I can write this very well, but we'll try. There's that 1 point, and again, there's that. Okay, all right, so this is how I like to do inequalities. I treat them as an equal sign. I'm just like, oh, I can solve it as an equal sign. But notice I want to know when, and I'm going to go down to this guy, the one that's been isolated and whatever. I'm going to look at him, not my original. When is this function greater than 6? Well, when is the absolute function above the line 6? Well, that's up here, right? It's this and it's this. So I don't need to do any inequality work. I don't need to do any of that. I can just look at my picture and be like, oh, so, and again, x values are when we typically do interval notation. So what x values do I have? Negative infinity, Where does my x value stop? Well, this key point, again, I don't care about the y values, only the x, right? So -5. Union, I'm going to pick up, none of these are answers in the middle. I'm going to pick up over here, what's my x value? 7, and it's going to go off to infinity, okay? And I'm going to do that. Now, some teachers might have done key points when you were in high school where you solve it as if it's an equal sign, and you have what? -5, and you have 7. These are wholes because it can't equal, right? It's not equal. And then you might have done test points. So you might have subbed in, say, a -6 for input to see what happens. Subbed in 0 to see what happens. And maybe subbed in 8 to see what happens, okay? So we could do that. But again, we want to go off our new function. So let's sub in 0. If I sub in 0, the absolute value of a -1, is that greater than 6? That is a no. If I put in 8, 8 minus 1, 7, yep, that's true. Sub in a -6, what is that? -7, absolute value, yep, that's true. And you see how this gives you a one-dimensional graph. -infinity to -5, not included. Nothing in the middle. Pick up at 7, not included, and go off to infinity. All right. Now, what if I change my sign? All right. So all I'm going to do is I am going to change my inequality, okay? So this is going to be now, let's do less than or equal to, just to kind of mix things up a little bit. Less than or equal to. Okay. Again, treat it as an equal sign to get those key points, okay? And then I'm going to erase all my junk over here. I don't know how well I can erase on a timetable, but we will try. All right. Okay. So let's look at what we're doing here. All right, so we have our key points again. And again, I know an absolute value function makes a V-shape, constant line is a line. And you want to use this in case there's a negative up here and it's reflected. And we'll talk about that in a little bit. But I have my key points are my two-dimensional graph. So, and again, I'm trying to do this without too much help here. Okay, there we go. Those are my key points. So look at what this is saying. When is this function less than or equal to 6? Okay, less than. Right? Greater than is up here, less than. So I'm looking for these outputs, right? These outputs, right, are less than or equal to 6. So then how do you do interval notation? Well, you're like, okay, well, they're both included. -5 for the x. Again, we don't care about y because the y is being described as being less than or equal to 6. So -5 to 7 inclusive. And again, I don't do any work with inequalities. I could care less, okay? Now, if your teacher in high school did key points, that's fine. I think to think of it, you know, in a two-dimensional is easier, but that's up to you. I have -5, I have 7. It can equal it, so I'm going to put solid dots. And then, again, I'm going to test my points. So 0 is always a good one. It's in between there. Absolute value, yeah, yes, that is true. So I'm going to shade that. 8 minus 1 is 7. Is that less than that? No. And what did we pick over here? I think -6 earlier. -7, absolute value of 7. That is a no. So then I have this, and again, that's between these guys right there. And I'm good to go. I don't memorize any of the tricks as far as do you trap it between this or any of that. All right, I want to do one with a negative because you do have to flip the inequality. So I'm going to pause for a second and we will try that. Okay, with this one, you can see we have a problem, right? Because if you look at this, this guy is reflected, right? And 8 is way up here. And so this guy's been shifted 3, right, to the left. And then it's been reflected. So they never cross. So you know there is no solution. All right, now from an algebra point of view, if I divide, isolate my function, absolute value function greater than -4, right? Okay. And then you're like, oh, shoot, no, that is not true, right? Because the opposite of this, did I ever opposite this? No, I did not. Remember, when you divide by negative, you have to flip the sign, okay? Now, so we can look at this function, same issue, right? This guy is going to be right there, and then -4 is going to be down there. Same issue, never going to cross. Now, if you do algebra, how do you know this? Well, if you do say, oh, x plus 3 equals, say, for some reason, absolute values can't be negative. I mean, you should be having issues right away. I suppose if for some reason you say -4 and 4, maybe test points are going to be like, but you do need to be aware. okay, that this can be a problem. Now, let's say this is a negative 8. All right, so I divide both sides. So opposite of this is that, opposite of this would be a positive 4, opposite of greater than is less than. So I do the inverse even of the sign, right? Not just, not just the numbers. And again, technically, you do that when you solve equations. You might not know it, but if you have negative 2x equals negative 8, when you divide by negative 2, you get x and 4. But technically, you're doing the opposite here, opposite here. You're also doing that, but the thing is with an equal sign is you can't tell if I flipped it, right? It still looks like an equal sign, right? So even if I opposite it and, reflect it or whatever, I'm still getting equals. So it's not a big deal. All right, but so again, when you do these with a graphical approach, you want to make sure, you isolate this function, not the original. Okay, so I change this to a negative now, we're in good. All right, let me get my key points, okay? So I have x plus 3 could be a distance of 4, x plus 3 could be a distance of a negative 4. Left or right? Because that's what an absolute value function's job is, spit out distance. 1, dead and dead makes a negative dead. Now again, this is not the function I'm looking at right now, so let me come over here maybe. Just want to get to the, sorry, I want to get to the, all right, I'm going to pause. Well, I couldn't get decimals to let me manipulate, so we're just going to stop here and we're going to, deal with it normally. Okay, at this point, I have a function that's been shifted, 3 back, 1, 2, 3. So I'm just going to make, and again, this is just a rough sketch, and then I want to know where it crosses 4, right? Okay, so it's going to cross at these 2 key points, 1 and a negative 7, right? Okay, I want my function to be less than 4. So I know it's going to be less than 4. The output is less than 4 down here. So what is that answer? That would be from negative 7, not included. So I'm going to use parentheses here. Sorry. Let me erase that. Parentheses, negative 7. And then it's all these are going to be answers that are less than, and then I go to 1. Okay? Because it's less than. If it was greater than, I would be up here, right? Now, if you want to do test points, negative 7 and 1, again, I could sub in 0. 3 is less than, yep, so that's good. If I sub in 2, 5 is not, that's a no. Maybe sub in a negative 8, negative 5, absolute value is 5, this is a no. And notice again, these are wholes or not included, and I can do it that way. So that's how I solve all inequalities. I don't do the algebra method. I just always do it graphically, because then I kind of know that I'm testing these regions, or I'm going below a line or above a line. Okay. All right. Hopefully that helps. You can read the book on the algebra methods if you want. I just never remember them, and I don't know, I have a master's degree in math and hasn't hurt me too much. So I just do more visual on these, and that works out well for me. So anyway, good luck. Hope it goes well. Take care.